Hello everyone, and welcome to the first lecture of the semester. I'm going to keep this brief and I'm going to talk kind of fast because I know how sleep-inducing watching a video of slides and someone talking over them can be, but there's some important information I want to get out to you guys before we really get going into the semester. So, without further ado, let's get moving. So, first of all, the A+ certification is a series of two tests. One is hardware-based mostly, and one is troubleshooting and software operating system based. You need to take both of them to become A+ certified. They are not free. They cost out of pocket, if you were just to buy them, I think $169 per test. You can get that at a much reduced rate through MATC. I believe, I'll double check, but I believe it's $89 per test. So it's still $180, but this is a course certification. This is one of those certificates that employers look for when they're looking to hire people, when they're looking to differentiate you from somebody else. They're going to look at your resumes. They might be the same. They're going to look at the certifications. A+ is one of those core certifications. Now, it is not a lifetime certification. It used to be, but as of 2011, they've changed it to where you need to be recertified every 3 years. This is a good thing because technology changes so fast. As we go through the course, you're going to find out that there's some things that we have in this course that are out of date. We're going to have, I'm going to be constantly making corrections to the slides and to the book, things that no longer are true or things that are new that are not covered in the book. So they did a good thing by doing this. The downside is you have to keep taking the tests. But the idea is once you get certified, once you get a job working in industry, these tests are going to be something you barely would need to study for because you're going to see this stuff every day. And also, it in itself, the content isn't that difficult. There's just a lot of it. So yeah, there's that. But I just want to stress that A+ is one of, along with Net+, one of the core certifications that people look for any IT professional. So the CompTIA exams, they do cover XP, Vista, and 7. They do not cover Windows 8. We will not be talking about Windows 8 at all in this course. We're not going to do a lot with XP and Vista because you're mostly going to see Windows 7. Not necessarily, well, both on the exam, but really out in real life, out in the real world. 7 is going to be the dominant operating system that you're going to find in businesses. And so we want to teach you the most important skills. You're going to need to know a little bit of XP and Vista for the certification exam, but I'm going to give you some tools that we can use to help get you up to speed with those without having to really focus on them while we're in class here. So the basic exam structure of the A+ certification exam, it's going to mirror the quizzes and the exams that we are going to give you in this course. Or the other way around, I should say. They're going to mirror the certification exams. They're going to be multiple choice questions. They're going to give you a very brief scenario, something in this case like a dot matrix printer is printing blank pages. What do you do? And then based on the information that we're going to give you and all the experience that you're going to get in this course, you're then going to try and figure out, well, what am I going to do? What's the first thing I'm going to look for? And then you're going to answer it. So that is the structure of not only the certification exam, but of the course quizzes and exams. They're going to be almost entirely multiple choice, and they're going to be essentially asking you questions. If you are in situation A, what do you do? So the two different halves of the certification. The first one is 801. This is largely hardware and networking. There's very little in the way of operating system troubleshooting in this part of the exam, and that's going to be essentially the first 6-7 classes of this semester is going to be spent on these topics, and then the labs will also correspond to these topics. And then the second half of the semester, we will then talk about the practical application, the operating system work, the software troubleshooting. Mobile devices we're going to touch on a little bit, security, things that are not hardware-based, things that you're not necessarily going to put your hands on. So you take these tests by signing up, registering with Prometric or Pearson VUE. We have a lot of Pearson VUE sites here in Milwaukee that we can use. You call them up, you register for exam. You can get a voucher from us, like I had said. It says here $199 per exam. I don't think I've ever seen anyone actually pay $199. I think that's like the MSRP price, but you will pay significantly less through MATC. You give them the voucher number, they set you up, you go, you take the exam. They have a room and a computer, you sit down and you take it, and it's timed. Hour and a half, I believe, is what you get per exam. So these are just basic strategies. I'm going to leave these slides up so you can go over them later. They're going to be on Blackboard. I'm not going to go too much into how to make good study notes and things like that. But you will need to do some studying for the CompTIA exams. And there are some extra tools that we'll talk about during the course of the semester that can help you if you decide that you want to take the certification exams. So let's talk about first the non-hard skills, the soft skills, the things that are not necessarily tech-oriented or tech-related of the job. If you are a tech, and I'm going to be speaking as if every one of you is going to go out and get the job in a company where you are responsible for fixing things, because that's what A+ is about. It's about troubleshooting and repair. If you are, there are a couple things that we want to talk about that are not, like I said, technical skills. Things that I'm not going to be giving you a test on by any means, but they're really important. So appearance matters. Now, I'm gonna make one quick statement about this. Other than yes, you should look nice. You should. Every company has their own dress code. You follow whatever dress code they give you. I will say for men and for women, do not wear a tie when you are working actively as a tech. When you're interviewing, go the full 9 yards. Get as dressed up as you can. The company may even tell you you need to wear a suit and tie when you go to visit the place. As soon as you get there and start working, take the tie off. A very quick anecdote, we had a printer repair guy that came into our office, and the first thing he did when he got there was took the tie off, and we commented on it. He said, yeah, there was a time where I would wear it all the time, and then one day I had my tie get stuck in the roller of the printer, and it started feeding me down into the printer, basically sticking my face. I got my face covered in toner, my shirt covered in toner, and the tie ripped. So after that, he never did it. And it's very true. If you are leaning over any device and trying to repair something, a tie is going to get in the way. If you have long hair, you guys can't see me now, but I have long hair. You need to fasten and secure it so it doesn't fall into, say, a fan that you're trying to work on. Very important to keep yourself comfortable. And on that note, for women, and I suppose for a guy too, if that's what he wants to wear, do not wear a dress when you go to work. Because if you have to repair a computer, very often computers are under desks. They're in places that you have to be crawling on your hands and knees to get to. We don't want you uncomfortable or worrying about displaying things you don't want to display to people while you're trying to work. You need to be relaxed and comfortable and ready to move around. You're going to get dirty in this job if you do on-site work at all. If you're in a call center where you're sitting at a desk, that's a different story. But for techs, field techs, people that go out and repair things, wear comfortable pants, khakis, business casual kind of clothing if they allow you to do that. But you do want to look professional. You don't want to look like you just walked out of class and you came to fix something. It's not going to engender trust with the clients that you're going to be meeting. So honesty and integrity are two different things. I leave the slide in because I wanted to make a point that you need to be as honest as you can with your clients. And I say honest as you can because there are times where they just don't want to hear the truth, and so you can tell it to them and then they're just going to ignore you or get mad at you. That's fine. Don't lie to them. Don't ever tell them something that's not true. But there's going to be times where you're just going to need to suck it up. Don't engage them in an argument of any kind. Okay, being honest within limits. At a point, you don't want to lose the client. You don't want to get people upset at you. Go to your boss. Talk to your boss. Let them handle it. Your job is to go in and fix things, not deal with people's personality problems. So you need to be able to tell the truth, and you should tell the truth. You should never lie to a customer. The quickest way to lose customers and get a bad reputation is say something untrue. If you are not 100% sure that something is true, then you shouldn't say it. When someone asks you, hey, do you think that if I put more RAM in here this will be faster? Well, your answer should be, there's a good chance it could. But don't ever promise them something if you're not absolutely certain that something is going to make a difference or do something. So that said, every business has its own ethics and integrity issues and policies, but just remember that integrity is doing the right thing, which is sometimes not the same thing as telling the truth. It may be simply not saying anything. So That is not sanctioned by the book. I'm sure that would be marked wrong, but that's the way it is out in the real world. They tell you in the book specifically, don't write down passwords, don't copy things down. You have no choice very often. If you are going to be working with 7 people's computers and they all have passwords, unless they're all going to be sitting there ready to give you or type in their password while you're working, you're going to have to write it down. I mean, don't save it. Keep it on your piece of paper until you're done working on their machines and you don't have to log in anymore. Then throw it away. But this concept that you should never keep track of things like that or never learn passwords, it's going to happen. Just don't. You have to be smart about it and don't use it for anything other than to get in the computer to fix it, right? That's the point. That's called ethics. Also, when you sit at someone's desk, because you're going to sit at their desk and it's going to be a mess, it's going to have little troll dolls and things all over the place. You're going to have pictures and you're going to have to move things out of the way to get at stuff. Ask. If there's no one around, make sure you put everything back exactly as you found it. Try not to move things. Imagine someone walks into your house and then goes into your room and fixes something, but then moves everything out of the way to fix it. So you come home and there's a bunch of stuff just thrown on your bed because they had to move stuff to fix it, right? You wouldn't be happy. They wouldn't be happy if you moved stuff from their desk. So try and avoid doing anything that, basically, I guess what I want to say is when you're done, it should be like you were never there except everything is fixed. If you keep that in mind and try and work like that, you're going to be fine. So dependability and responsibility, these are things in the book I'm not really going to talk about because, well, you can read them and most of it is common sense. I do want to talk about paperwork, though. Paperwork is the most boring and hideous thing about any of our jobs. It takes up time and we don't like it, and it's really not doing the main part of the job, the fun part of the job, fixing things, but it's really important. Documentation is critical. It's critical for customer service. It's critical for getting paid an awful lot of the time. It protects you from litigation, from getting sued. It is the single most important thing you can do as a tech outside of actually fixing things is documenting everything you do. It's also very important that you document things so that techs that come after you, if something breaks, they know what you did already. And so they know either this was a problem before or I fixed it and this is what I did. So you can point them in the direction of what went wrong, and they're not having to redo all the work that you just did. So paperwork, very important, not fun, but very important. Now, communication, they use assertive communication. I like to call it accusative communication. In other words, when you're asking someone about something, you're trying to figure out what happened. You want to figure out how to fix it. So you have to ask them, well, what's going wrong with the computer? Well, don't ever say, what did you do to the computer? Or when did you break the computer? Things like that. You may laugh, but I have heard techs say things very similar to that, and it gets people very defensive. If people are defensive, they're not going to be very honest with you, and seriously. You want them to just simply tell you what happens. Most of the time, if you're brought in a situation, something happened, something broke, and these people are terribly afraid that they broke it. The reason you're called in is because they don't know how to fix it. They don't know what happened. And the machine cost about $1,000 and they didn't buy it. It's the company's computer. And so now they're worried about getting blamed for something that may or may not have been their fault. So they're going to be all uptight about it anyway. They're going to be unhappy. They're going to be nervous. They might even be frustrated. And so you don't want to be making things worse. You basically just want them to report what is going wrong. You don't care about blame. They think you do. They're worried about blame. You don't worry about blame. You're just there to fix the machine. So when you're phrasing questions, you want to find out. Usually, the first thing you want to find out is when did whatever it is start. And I say usually because very often something wasn't always some way. It just happened to start not working at some point. So finding out when. So instead of saying what did you do to it or when did you break it or anything like that, just start with, how long has this problem been going on? When did this problem start? Is this problem affecting just you, or is it affecting everyone in the office? Things like that. Always focus on the problem, not how did it happen, not who was the last person to use the computer when things like that. They're going to volunteer that information for you. You're not going to have to ask for it. Keep everything in the passive voice, I guess is the best way to describe it. It sounds silly. It sounds like you're playing games. You're not. You're trying to get the bottom of it. You're trying to get the information out of them. And the best way to get information out of somebody is to make them not feel like they're under attack or not feel threatened or not feel nervous about something. Okay? So we're not playing games. We just really want to get the information. And the best way to do that is to seriously to just keep everything very passive and very just the facts kind of communication. The other thing I want to mention, and I left this slide in specifically, don't ever answer your phone while you're working with a customer. If it's critical, if the house is on fire or you absolutely have to take something, excuse yourself, walk outside, and be very quick about it if you absolutely have to. Otherwise, call someone back. The quickest way to turn someone off, to make them know that you don't care about what the problem that they're having or about fixing their machine, is to just simply start having a conversation or doing something that is not directly related to what you're doing. Don't talk on the phone while you're working. Don't have your phone anywhere other than in your pocket. And when it goes off, only if it's an emergency or you have to respond to it do you pick it up. And then you apologize and excuse yourself. And then you apologize again when you come back. The rudest thing that you can do, and this is true across any business, is to take out your cell phone and start talking when there's business being conducted. Okay? So that's why I left this one in here. And I talked about this. Expectations. Never guarantee something. Give estimates. And I say that because you might know it's only going to take you 15 minutes, but what happens where 10 minutes in you realize that there's a much bigger problem, that now that you've opened up the computer, you're seeing something else, and this is not going to be that fast. Well, now you lied, right? Instead, because you guaranteed, you said, yes, I can have it done by then. Well, you were wrong, and you didn't know that you could have it done by then. You just had a feeling that you can get it done. So give estimates. Say, I think it'll take me about this long. If that changes, always let the customer know right away. Don't just keep doing work. If I said this will take about an hour, but it's going to take about 2, that's money. You want to let the customer know right away. This is going to take longer. Ask them if they want you to continue with what you're doing, or if they maybe want to pursue a different option. Because sometimes replacing a computer is cheaper than fixing a computer. And if they're not really married to that computer, if they don't love that computer, well, they may tell you, okay, don't even worry about that. We'll just do something else. Okay? It's very important to stay in constant contact and communication with the customer. They may be a little annoyed if you're doing that, but at the same time, they're going to appreciate knowing that they are making the decisions, that you're not just doing stuff. Imagine if you had a car, you took your car in, and you just get an oil change. And then you came back, and you have a $400 bill, and they were doing an oil change, but then they noticed something needed replacing, so they just replaced it. And oh yeah, your brakes, we needed to replace one of the pads in your brakes, so we just replaced them both. And so here you go, it's $500 now or something. You would be very unhappy. It's the same thing with a computer. If you are doing something and you realize something else has to get done, it's going to be more money, you don't just go ahead and do it and then give them a bill that they weren't expecting, right? You talk to them. You let them know. You let them make the decision if you want to do that or not. And again, this is where documentation comes in. If you leave something, if you don't fix something, you see it's there, you write it in the documentation. You make sure the customer knows. If they say, no, don't do it, write down, they didn't want me to do it. Things like that. This is essential. This is like business communication more than actual tech work. But this is a very critical component of tech work. And this is the only time I'm going to talk about it in this class. But it's a very important thing that we need to keep in mind when we're actually out doing our work. So safety and tools, they have an awful lot to say about safety and electrostatic discharge. I will say that ESD, which occurs, things like static electricity. When you store up a charge and you touch something, you get a shock, like in the wintertime around here it happens a lot. It is a serious problem only in that if it happens in just the right way, you can destroy a piece of equipment. Now, it is very difficult and very rare for this to actually happen. In all the years that I've done this kind of work, I've seen it happen exactly once. And it was an enormous shock, and you could actually see the damage done to the device. It was some RAM. It used to be a real problem. And in certain situations, it can be a real problem. So what I recommend doing, well, here, let me talk about what they recommend doing first. They recommend using an anti-static wrist strap or having it on a mat where it sucks up a lot of the static. And then you have, as you can see in the picture, you've got the strap with stuff like hanging from it. It makes it really difficult to do work. I really don't like these things. They serve a purpose, but I don't like them. What we tend to do in the businesses and places that I've worked at is we do something called discharging, where as we are working throughout the day, as we are walking around the building, we are constantly touching pieces of metal. So essentially you're constantly shocking yourself. You don't really feel it because you're doing it all the time, so you don't build up a big charge. But you're constantly discharging the electrostatic energy that you have. And as a result, when you go to touch the machine, you're not storing up all that electrostatic charge. Touch the side of the machine first before you go in. Make sure you're holding onto a piece of metal or something, grounding yourself, if you will, before you go in and touch something. Now, that's reality. That is what you're going to do when you're actually out in business. When you are taking an exam, talk about anti-static wrist straps and anti-static mats. Okay. Anti-static bags, when you buy hard drives, they almost always come in these bags. They're actually really handy because they do a good job of keeping electricity away from components that you're storing. So I never throw them away. I have a drawer full of anti-static bags in my office, and when I have a hard drive I have to take out and do some work on, I just grab a bag and I throw it in there, and it helps protect it a little bit, because just because you don't have electrostatic energy or charge doesn't mean that something around the office doesn't. And it doesn't. I mean, this is a good way to protect it both from dust and from any stray charge that may be coming around the office. And just as a side note, always unplug the PC before you open it. Don't just turn it off, because there's still charge going through the whole device. I know people that like to leave the computer running when they open it up, and so they can look and see what's going on. It's just a bad idea to stick your hand in there when something is running. Mostly, not because you're going to hurt yourself necessarily. I mean, you could if you get your finger stuck in a fan or something. But mostly, you can really damage the computer if it's running and you go and you start moving things around. Then you really have to worry about what you could do. So always unplug it. Let it sit for a couple seconds. Let the charge go away from the motherboard and so on before you mess with it. EMI is not the same as ESD. Electrostatic discharge is like a static shock. EMI is a magnetic field, and that is a good example is when you have a large engine that's moving, and so you have like two magnetic fields, two large metal pieces moving next to each other and generating a magnetic field. This doesn't destroy electronics. If it's incredibly powerful, it can destroy electronics, but usually what it does is it interferes with wireless signals. It interferes with Bluetooth, with Wi-Fi, things like that. It can even interfere, if it's strong enough, it can interfere with an internet connection, an Ethernet cable. Because if you have an unshielded cable, that interference can go right through the cable and affect your data. So it's common among large manufacturing companies. You can have, if you have a big machine and then you've got some wiring running anywhere near that machine, when it's running, that EMI could really affect the network. So ESD is a shock that can affect components and damage them. EMI is a field that can interfere with wireless signals. RFI is another way to interfere with wireless signals. Imagine, if you will, you are right next to a radio broadcast tower. There's an awful lot of waves coming out of that tower, and that mostly will not affect electronics and stuff. Communications get disrupted. If you've ever had an old analog cell phone, sitting next to computer speakers, you've heard RFI. You've heard like the speaker will start. You'll hear some like static and some sharp punches, and then it'll before the phone starts ringing. That is RFI. So physical safety. I'm not going to say too much other than common sense. Lift with your legs, don't bend over, don't wear long dangling jewelry like earrings or necklaces. If you have long hair, find a way to secure it before you mess with equipment, things like that. And the rest of this I won't really worry about. Take a look in the book, though, if you have any questions about it. I will say this is a very common sight in many network closets. You want cables to look nice. Very often when you come in, they're not going to look nice, and that's the way it is. some part of our job as network professionals is to keep all this in order and keep things looking very nice. But as soon as we leave and people start moving things around, this is what happens. Yeah, so. Another thing, when you are working with a machine that has been running for a long time, there are parts that are really hot. And I mean really hot, like, 80, 90 degrees Celsius kind of hot. Heat sinks, those big metal things that go on top of the CPU itself, they get very hot. You don't want to be handling them right after turning off a computer. So give yourself time once you unplug and open up a computer to let things cool off before you start touching them. And I'm going to go over the toolkit next week. I'm going to bring mine in so you guys can see up close what some of these things do. So we have one last section. And this section is probably the most important. I've been babbling for, I'd say, about 25, 30 minutes about things that are mostly related to teching. This is the first part of actual teching. We're going to do 3 different visible sections. The first one is the visible PC, and this is all we're going to do for today. The visible PC, stuff that you can see. Before we actually get into how things work and how things get put together and stuff like that, we're just going to try and get an overview and get an understanding of the stuff that you can see on your computer, specifically your desktop computer. I know they have a laptop showing there, but we're going to be talking about desktops. So the PC has 2 things. It has hardware, it has software. Hardware, Mike Myers likes to say, the pieces you can kick. If you can feel it and touch it, it's hardware. Software is stuff that you can't feel and touch, but stuff that's equally important to the computer, the operating system, how stuff runs, right? Applications, things like that. So we're mostly going to be talking about software, but you need to know at least a little bit right now how things are working together. So a computer is all about ones and zeros. More specifically, it's about electronic impulses. So what happens is the computer is constantly pulsing, either sending a signal or not sending a signal. There's a clock in there, and so for every, they're usually about 3 billion times a second, there either is a pulse or there is not a pulse. If there is a pulse, it's a 1. If there's not a pulse, it's a 0. And that's how they do binary on a computer. So a computer will be sending these ones and zeros, pulses of either pulsing or not pulsing, and then they combine that into some form of information. If you're curious about that, there are whole courses on how this works. But really, you just need to know that that's what happens, is that there's all these electrical pulses, going through the computer, and that's making up the ones and zeros. Really, there are 4 sections to how a PC works. I was saying there's hardware and software, but really it comes down to input, processing, output, and storage. Input is getting information into the computer, whether it's a keyboard, a mouse, a microphone, a webcam, or a trackpad, or a drawing tablet, something like that. Anything that puts information into the computer from you. Okay, that's input. Processing is the actual manipulation of the data. Processing essentially is just the CPU. It can also sometimes be a GPU, a graphical processor unit, and then there's a couple of other small chips in the computer. But primarily, processing is handled by the CPU, which stands for the Central Processing Unit. The output is essentially, once it's processed, it's got to give you the information. It's got to give something. In the old days, it was this tape, where it was a long string of ticker tape where it would type out information for you, and you would read the tape. Later on, we had monitors where you could actually see. It would display text, and now we display graphical images. It can be a printer. A printer can give you the information. It can be speakers. Speakers can output the audio that you've been working on, things like that. And then finally, storage. Storage is how we keep that data and so we can manipulate it. Storage is not the same as processing. So you don't process with RAM. RAM just holds the information to be processed. The hard drive holds and stores that information so we can retrieve it at a later time. So that's what storage is involved. So, yeah, the art of never mind, we're not going to worry about that. External connections. This is probably the most important part of this lecture, is what is recognizing and understanding what these different external connections do. This is an example of, if you were 18 months in the field, you would just be able to look in the back and know instantly what all of these parts are. But if you've never had to deal with them, you might not know. So that's what we're going to focus on for the rest of this lecture. So you have plugs and you have ports. The plugs are essentially the male, not always, but usually the male end. They get plugged into a port. Sometimes people call ports jacks. Please don't do that. A jack almost exclusively used to mean a telephone jack. We don't use telephone jacks anymore. So they are ports. Always call it a port. So a port will take the plug. And think of it like if you're plugging something into the wall, the plug, we call it a plug, right? That's the plug. The wall, the outlet there, that is going to be the port. Now, a connector can sometimes be a port. In other words, the connector itself can be accepting something inside it like a port. We use the term male and female to describe this. I'll leave that to imagination how we came up with that. But male and female ends have to meet in order for the port and the plug to work together. So there are 6 basic types of connections. Now, there technically are 7, but really the first one in this list, the mini DIN, is going away, so there really are only 6 nowadays. So I'll talk about the 7th one when I finish with the others. So a mini DIN is an old, what we called serial connector. This was used primarily to plug in keyboard and mice into the computer. There were other uses, but mostly it was keyboard and mouse. The old DIN was very large and had 5 pins. The mini DIN has 7 pins, 6 small ones and 1 large one, and you can see by the picture here what they look like. The mini DIN is also sometimes known as the PS2. This came out before the PlayStation 2, so there was no confusion when it was first called PS2. Those specifically were used for 2 things: the keyboard and mouse, like I had mentioned, but they were also used for an old kind of video called S-video. So you may actually see a mini DIN connector in an old graphics card because that's what it would send out. But nowadays, you don't even see them. You can't buy machines that have these anymore because USB has replaced them. So when you go to work on a machine, you might find an older machine that still has this. Some of our lab machines are certainly going to still have these, but they are essentially gone. You're not going to see them anymore. But if you do see them, and for the purposes of the exams, they are for keyboard and mice. USB, which is probably the most important invention of the late 90s, and I mean that seriously. Universal Serial Bus has so many advantages over the old serial, the mini DINs that we just talked about. First of all, they are universal. Everything uses them. They are hot swappable, meaning that you can just plug it in and it'll work. A lot of the old serial devices, you couldn't plug it in when the computer was on. You have to turn the computer off, plug it in, and then turn it on. Then the computer would recognize the component that you plugged in. Now you can just plug things in and unplug them, and you're not going to blow up the system, and your component is going to work. There's 2 ends to USB. There's an A and B end for the regular size USB that we're all familiar with. The B device is a little bit bigger. It's almost a square, but it's got some notches on the top. That plugs into devices. Like if you have a USB printer, the B side plugs into the printer. The A side is what plugs into the computer. That's the flat side. Sometimes you'll see a cord that has 2 A sides to it, and that is meant to plug 2 computers together. There are 2 smaller kinds. There are of USB. There's also mini USB and micro USB, and essentially they are smaller versions of USB. They have slightly different shape. They are used mostly for smaller devices like phones and such, but they're not all that common. All of them can send power across the wire, so you can charge things. You're all familiar with being able to charge your phone with these cords. That was a new thing. That was with USB. That did not happen before. You can use the USB to power your hard drive. That was not possible before USB. So that's one of the many reasons why USB is really, in my opinion, one of the best inventions of the late 90s. So here we have a picture. You can see the top one is the USB-B connector that plugs into the device. USB-A is over on the left, and that plugs into the computer itself. And down below is an image of a mini USB. Micro USB really looks like mini USB, but it's even smaller and flatter. And it's very important that you can recognize all of these kind of ports and devices. Okay, the key to this discussion is knowing the different kinds of ports and plugs that we have. So FireWire is it was mostly used by Macintosh, but PCs used it as well, as a way to send audio and video. There's a number of technical reasons for that, but essentially that was what it was used for. It can also be used to connect Macintosh computers together to use for various purposes. It has a 6-wire, a 6-pin connector that is a little trapezoidal. It's not. You can see that it's not exactly square. There are some smaller mini FireWire ones that are 4. There's also a larger one that has 9. That's called a FireWire 800 port. Really, you need to know it's FireWire. It's known as IE 1394. Those are the two names, and that's really what you'll need to know. And again, they do the same thing, same basic thing that USB does, but they do it in a different way. They also can send power. Again, they don't get used by many things outside of audio and video production. Now, DB connectors, that's a whole family of connectors. About 10 years ago, 20 years ago, it was way more important. There were a lot of DB connectors in use. Nowadays, you're only going to see really 2 kinds of connectors. You're going to see the larger 25-pin one that's being shown here that is almost exclusively used for printers. That's called a parallel port. It's used for printers. And you can see that it's longer and it's colored kind of purplish. That is a printer port. There were many, many other serial ports that we use, like for modems and for joysticks and things, but nowadays we don't. The only other one you're going to see is below the purple port. You're going to see a smaller 15-pin one that's a little bit thicker and a lot shorter. That is not even, I mean, it is a DB connector, but that is actually a VGA port. That's a graphics port, and we'll talk about that in a little bit. So RJ connectors, these are the communications connectors. They were initially, going way back, these were the original telephone connectors. If you still have a landline in your house, or if you have DSL in your house, you have an RJ11 that goes into some device, whether it's your phone or a modem in your house. RJ45s, on the other hand, are the larger ones that we use for Ethernet connections, the ones that we use for our computers. And I'm sure you're all familiar with and have seen these connectors before. Now, audio connectors, again, you guys all have headphones. You know what the little 1/8-inch jack, the mini audio jacks are. You know what they look like. They get plugged into the back of the computer. Now, you'll notice that there's always more than one of these in a computer if you're on the back. That's because you have to have one for the speakers or the headphones. You need one for the microphone and sometimes other audio devices. On newer machines, you're actually going to see 6 of these, and sometimes even 8 of these, and that's for surround sound. They're all color coded, and they have their own way of matching up. But the green one is always the regular stereo jack. So if you're looking in the back and you see a bunch of jacks, the green one is the one that you want to plug into if you're just trying to plug in headphones or some little speakers. And here are some of the color coding that you're going to see. This is not universal. Not every machine has this, but in general, if there is color, these are what they are. A VGA connection, which is that DB, the 15 DB connector, that's always blue. The parallel one for printers is going to be burgundy or purple. The audio line in is blue. Audio line out is that lime green. Microphone is pink. And then the PS2 mouse and keyboard are green and purple. Now, for the mouse and keyboard, you can swap them. That really doesn't matter. They actually just did that so people know that there's 2 different things to plug in. They function exactly the same, so you can switch them out and it won't make a bit of difference. So now, devices. I've talked about the different connector sizes here. The devices that you use these different connections for. You can either have on board, which means it's connected directly to your motherboard, some ports that you can plug in, or you can have expansion cards. And we're going to do a lot more with these. We're actually going to have you install expansion cards and so on later in the semester. Graphics cards are generally the most common expansion card these days that you're going to see. And they will have different ports on them. So first, we talked about keyboard, the mini DIN connector, which is, if it's a keyboard, it's going to be purple. It's the PS2 connector, right? Monitors. Now, there are many different kinds of monitors. Notice I had mentioned the S-Video using the same mini DIN connector over on the left there. That's old. You're probably not going to see those much anymore. The center one is one we haven't talked about, and it's called a DVI, Digital Visual Interface, or Digital Video Interface connector. There are 2 kinds of these, and so it's very important that you're aware of this. You see with this one, there are on the right side, there are 4 holes that surround what looks like a plus. Those 4 holes are for audio. You can send audio through that kind of DVI. It's called a DVI-A connector. They make DVI connectors that are just DVI-D or only video that do not have those 4 holes. The problem is if you have a cable that has those pins, has those holes, and then you have a port that does not have those holes, they are not compatible. You can't plug it in because there's nowhere for those pins to go. So be aware that there are different kinds of DVI ports and connectors. But they both function roughly the same in that they send a digital video out. Now, digital video is important because the one on the left and the one on the right, the left one, the S-video that I just talked about, and the one on the right, the VGA port, those are analog video signals. And there are times where you are not able to convert from one to the other. I'll leave it at that. We'll talk about that a lot more in the video section. But the most common one that you're going to see is the one on the right, the VGA connector. In fact, I would be surprised if the lab machines don't all use VGA connectors for their video. Now, there are several new video ports that are out there. The most common one is the HDMI connector. Anyone that has a modern HD television probably uses HDMI. You can send video and audio over it, and there are machines, more and more computers are coming with HDMI connections too. So you can plug into HDMI capable monitors. Now for sound, I had mentioned the bank of the 1/8 inch audio jacks and how they work for surround sound. I do want to mention on the right that DB connection that you see there. It's a DB15, but it's a different shape than the VGA connector. That was actually done for 2 things, either for an old joystick. We used to have joysticks that we would plug in, not game pads. And then it was also sometimes used for something called MIDI, which is a form of electronic musical instrument communication. Now MIDI goes over USB, so that this is essentially obsolete. But if you ever see something like that, that's an audio card, and that's what that was for. Now, one other kind of audio, and this is a more modern kind of audio, is the digital interface. There are 2 kinds. There's optical and coax. Coax is the same thing that you would have if you would plug into a cable modem. It's round and has a sharp pin on the end. Coax audio tends to have a round connection for that pin, but it plugs in. The orange on the left is a digital coax interface. The one on the right is a digital optical interface. It's a special optical cable that literally sends beams of light, and that's how it sends the audio back and forth. And this takes care of all of the connections. You can handle up to 9.1 on surround sound with these, and you can even do in and out audio, so you can record and play back from the same connection. Networks. So the Ethernet, the RJ45 jack, that is the main network connection that we're going to talk about. There are a couple others, but most desktops are not going to see them. We're really not going to talk about them in this course. The mouse, similar to the keyboard, used to use the old mini DIN. They all use USB now. You can call a trackpad or a rollerball a trackball like they show here. These are all different forms of essentially pointer movement or mice. They also, nowadays, you can even do touchscreen, but that's a whole other animal that we'll talk about when we get to mobile devices. You will hopefully never have to deal with a modem. If you ever do have to deal with a modem, know that it uses RJ11 plugs, and very often they require more specific setup. And I'll go into a little bit in the networking section, but you'll very rarely see a business that still has a modem available. Printers almost always use USB, and now it's actually becoming more common that they use Wi-Fi connections to communicate with computers. But you may still see some older DB25 jacks like this. Again, the burgundy purple ones, those are the parallel ports for printers. And we call them parallel ports because they can send and receive information at the same time. Again, a joystick I had mentioned about plugging into an audio card. Oh, I hope you never see one of those. Now, eSATA is a recent connector that was meant to basically replace older USB connectors because of the speed, but the new USB 3 connection is really not as fast, but really close, and there's a lot less problems with configuration for SATA versus USB, and so that's kind of, you'll see eSATA ports, but they don't get used nearly as much as you would think, considering their speed, which is significantly fast. So, opening up, if we look at the system unit, we have the case, right? Everyone is familiar with what these big boxes look like. The front almost always has a power button and a reset button and some LEDs that help tell you what's going on. The back is where the vent for the fan happens, and then also where all those ports are, so you can plug things into your computer. Okay, this is typical. You also have some ports, usually USB and audio ports, on the front of the computer, and that's mostly just for convenience. But they function exactly the same as the ones in the back. You also, if you have an optical drive, a DVD drive, that will be on the front of the computer and you'll be able to access it that way. That's becoming less common. There are machines increasingly coming out that do not have any optical drive at all. I'm going to go over this in much more detail in a few weeks when we actually take apart a machine, so I'll skip that for now. The CPU is what handles everything. That is the brains of the computer. It is stored underneath a cooling fan that has a large metal sink. It's called a heat sink that takes the heat and distributes it, and then the fan will blow it away to keep everything from getting hot, because a lot of heat gets generated from these CPUs and they can melt. It is quite possible to melt a CPU if you let it run too hot. There are many different types of CPUs. Nowadays, though, we are pretty much stuck with three makers. They are saying just Intel and AMD. There's also the ARM, Motorola ARM processors that are used for phones and tablets that you see a lot of. The models that they have, these are a little bit out of date, though really the Core model is what we use now for Intel, the Core i5s and i7s, and maybe i3 still. And AMD has a whole new line that I can't even remember the names of anymore. I'm sorry. But they tend to work the same way. The architecture is different, and the key is whatever make you have, the motherboard has to be the same model. In other words, if you have an Intel chip, you have to have a motherboard that has an Intel socket that you can stick that chip into. Otherwise, they're not going to work together. RAM essentially is the same way. RAM has a whole bunch of different speeds and sizes. You no longer are going to see RAM measured in megabytes. That would be very old. Nowadays, they come in 1 or 2 or 4 or 8 gigabyte sticks. The most common one today is going to be the DIMM, the dual inline memory module. That's a standard stick of RAM. As you can see from the picture, they have a bunch of pins on the bottom, and there's a notch. That notch is slightly offset, and so certain kinds of RAM, that notch is in a different place. What that means is you can never put the wrong kind of RAM in. If you try and put it in, it won't fit. Another just key when you're installing RAM, never force anything. If you have to do too much pressure, then chances are you're doing it wrong or it's not supposed to be there in the first place. And we're actually going to talk more about RAM later, so I'm just going to leave it at that. Now, motherboards, this is what allows everything to plug and talk to each other. Okay, the CPU is the brains, the motherboard is the body. This is what's going to, the nervous system, I'd say. This is what's going to actually allow everything to communicate, and you plug everything in and be able to interact. Ta-da. The power supply uses, in the United States, a 110 volt VAC, volt AC power from the wall outlet. Basically, you plug it in like you normally would with a 3-prong grounded plug. On the other side, it has all of these small specialized connectors that plug into other parts of the computer and power things like the hard drive and the graphics card and the fan and things like that. Usually these things are what we call keyed. So the same holds true with ports and connectors, in that you can't plug something in wrong because it won't fit. So if you're trying to plug something in and it's not fitting, look to make sure that there isn't a notch in the wrong spot. And so for all of these power cords, you're only going to be able to plug in the right amount of power to the right device. That was not the case about 10 years ago, 15 years ago. That is true now. And, oh yeah, and I will mention that that power supply holds a charge after it's unplugged, sometimes for a very long time. You will hopefully never see a floppy drive by the time you get out of here. They are going away. They've been going away for years. But you may encounter one. And so and you'll probably encounter one of these, the quote-unquote newer ones, the 3.25-inch drives, the 3.5-inch drive, that you're seeing here. They have their own special connection that attaches to the motherboard. It's small. It has a number of pins. And when we do the drive section, I will go over a lot of these. Hard drives. Now, the thing about hard drives is that they've changed a lot in the last several years. You most likely will never find a PATA and IDE drive anymore. PATA and IDE are interchangeable terms, meaning a drive that has 40 pins, like little tiny metal pins that send communication back and forth, and there's this flat cable that connects to them. They don't make them anymore, and you're probably not going to see them. Mostly what you're going to see are the serial AT, the SATA attachments. They look different, they're easier to plug in, they're faster. So essentially that's the one connection that you're going to see for most hard drives. The SCSI is also a legacy connection that looks very similar to PATA in almost every respect. It's a little bit different though, and I'm going to explain them when we do hard drives, but you're not really going to have to deal with them. So we have pictures there for you, but again, we'll talk about that later. DVD drives use the same connection that hard drives do, whether it was PATA or SATA. Now, as far as optical drives, we do have 3 types, but there's really subtypes among these. So there's CDs, which is what used to store music. I don't even know how many people buy CDs anymore. There's DVDs, which are more for digital video discs, and they store more data. And then there's the Blu-ray disc that is the most common modern disc. Now, there are subdivisions of these that we'll get into when we do the media section. But just be aware that not all DVDs are compatible with every computer and every drive. The same is true with CDs. The same is true with Blu-rays. So that is it. That is the end of, and with that, that is going to end this lecture. I know I did a lot of talking. I tried to get through as much of this as I could and not put you all to sleep. So I hope you got something out of this. We'll be talking more about this a little bit next week. I'm going to have some examples of things that I can hand out so you can actually feel and touch some of these ports and cables. And with that, have a good day. Make sure you do your online quiz for chapters 1 through 3, and that would be the only assignment we have. I will see you next week, September 10th. And yeah, that's it. All right. And I will see you guys on September 10th.